welcome to Reference Angle Podcast. So we're going to use our reference angle to find the exact values of trig functions. Okay? And this is podcast number 2 for today. And I think I can get this in less than 30 minutes. All right, so we have a principal angle, which is the counterclockwise angle between the initial arm and the terminal arm of an angle in standard position. Its value is between 0 and 360. Or if you're in radians, 0 and 2 pi. All right, so when we were finding coterminal angles, when we added another 360 or when we subtracted 360, those weren't the principal angles. Those were coterminal angles. Those were other angles that started and stopped in the same location. We want the principal angle to be the simplest one. So if our angle is more than 360, we're going to find a coterminal angle to give us the principal angle, because our principal angle is going to be between 0 and 360. We're going to use that angle to find a related acute angle. Okay, so you see the theta and the beta. If you look on the diagram on the right hand side there, it shows you principal angle is the blue angle there with theta on it, and the related acute angle is beta. Notice it's not starting at the initial side, not starting at the initial arm, and it doesn't have to, but we have a way to figure out where it will start. It's a very special angle. That related acute angle is going to be an acute angle that lies between the terminal arm of an angle in standard position and the x-axis when the terminal arm is in quadrants 2, 3, or 4. So in other words, we're going to find another angle that's going to take us to the x-axis, and we're going to use that angle to work with. That one is the friendly angle. Okay? Sometimes a larger angle, they're not as friendly to work with. But our little acute angles, those are very friendly to work with, our related acute angles. Notice it doesn't say in quadrant 1. Quadrant 1, the principal angle, doesn't need a related acute angle because it's already a cute little angle. All right, so reference angles, they are the acute angle formed by the terminal side of the angle and the horizontal axis, the x-axis. We always head to the x-axis when we create our reference angles. And we always head the fastest way to the x-axis. Right? So we aren't going to go all the way, if you notice my picture on the side there, and we're in quadrant 2, we're not going to go all the way back to quadrant 1. We're just going to head to the x-axis that is in quadrant 2. So remember, it must be positive and it must be acute. If our reference angles aren't positive and aren't acute, then you have made a boo-boo. And I think I have a little sample one, and then I'm going to show you the rule for these. So sometimes it's necessary to be able to make a larger angle smaller. We do this by finding reference angles, and this is a real key skill. I cannot stress the importance of this skill. It'll come up in pre-calculus, it comes up in calculus, and in all the math classes you're going to take beyond. You're going to need reference angles to evaluate. If you can graph reference angles, that'll help you so much out in other classes, because that comes up in a lot of other classes. All right, so here's our steps. We're going to start by drawing the given angle, whatever it is. There is a step 1.5. If your angle is more than 360, you'll have to find a coterminal angle. So I'm going to add a 1.5 here. If the angle, and this is only if the angle is greater than 360. If the angle is greater than 360, or negative, find a coterminal angle first. Boy, that looks a little funky there. And your coterminal angle, let's see if I can get the word coterminal in there. Your coterminal angle has to be between 0 and 360. So if we don't have a principal angle to work with, we'll get a coterminal angle. And I think I probably have an example where we have to do that too. All right, so now it's hard to read. Maybe I should put my step 1.5. I don't know where to put it. I guess I can put it here. I just noticed that it's a little in the way. Maybe if I do this and kind of block off 1.5 from 2, you can still read it. There we go. All right, so step 2, now we determine how many degrees is it till we get to the x-axis, the horizontal axis, right? And we want the fast way. This is your reference angle. A reference angle is always positive, right? So if you get a negative, you're going the wrong direction, go the other way. If you get something that's not acute, you went the wrong way. It's real easy to figure out what way to go, and it's very intuitive. And I have a little set of rules for you. So you have 2 things. So here I have a 140-degree angle. That is the principal angle that's graphed. I want the fast way to the x-axis. The x-axis, remember, if I go from the positive x-axis to the negative x-axis, I've gone 180 degrees. So that means that the distance I have to travel to go from that principal angle to get to the x-axis, how far do I have to turn? I have to turn 40 degrees. Right? So if I take 180 and I subtract, that's where I need to get to. I need to get to that x-axis. And I subtract my principal angle, which is 140, I'll get my reference angle, which is 40 degrees. So 40 degrees is the reference angle for 140 degrees. And that is an acute angle. Okay? It's that easy. Now, of course, we'll do some things a little bit different when we're in other quadrants, but it's still that easy for all the quadrants. All right, so I just want to go over, it looks like there's a lot of stuff up here, but it's really not that bad. I have this same diagram 3 times, 1 for each quadrant, and I show you what to do. So, in the first quadrant, I don't need to find a reference angle at all. Okay, so I'm all good because my reference angle is just what it is. Okay, but in the second quadrant, so this is actually pointing to the second quadrant. It's pointing over here. All right, so in the first quadrant, we have no reference angle. We're all good because I have an acute angle. No reference angle needed. In the second quadrant, my reference angle plus my principal angle is going to add to 180 degrees. Okay? So to find my reference angle, we're just going to take 180 and subtract the principal angle. So since r plus p equals 180, r, which is my reference angle, equals 180 minus p, which is my principal angle. So if the terminal arm of the principal, and I know I have this all in your notes on like a summary page that I'm going to get to. If the terminal arm of the principal angle lies in quadrant 2, then the related acute angle is calculated as your angle is just 180 minus your principal angle. That's all you have to do. That's simple. Just subtract from 180. That's your reference angle. That's the one we're going to work with because it's a friendly angle. We can work with it. If the terminal arm of the principal angle lies in quadrant 3, then our reference angle is calculated as, so notice here I'm past 180. Notice that if I take my reference angle and I add 180, I'm going to have my principal angle. And boy, wasn't my smartboard being a little finicky that day. Look at those arcs, for that red arc and that blue arc. Pretty pitiful, huh? But I'll leave it. So the reference angle plus 180 gives me my principal angle. So we want to solve for the reference angle. So if we subtract 180 from the principal angle, because we've gone more than 180 degrees, we're going to get our reference angle. Oh, and I forgot to mention what to do when we're in radians. So in radians, I think it's listed up here, or we're in radians, then we're going to, is it up here? Oh, there it is. It's right below it. So notice here, right here. So here's for radians. The reference angle plus the principal angle equals pi. So we'll just subtract our, I don't know why it says 180. We'll subtract our principal angle, that's what it should say, from pi. So pi minus our principal angle is our reference angle. So it's either 180 minus our principal angle or pi minus our principal angle. When we're in the third quadrant, right? So it's our reference angle plus 180 equals our principal. So our reference angle is our principal minus 180. And if we're in radians, our reference is equal to our principal minus pi. So right here I have those highlighted out for you. Right? So that's simple. So now instead of subtracting from 180, we are subtracting 180. What do you think we're going to subtract from when we get to the fourth quadrant? What will we be heading towards? So we're going to be headed towards 360 degrees. So if the terminal arm of the principal angle lies in quadrant 4, then the related acute angle is calculated as 360 minus our principal angle. So notice here that together the principal plus the reference, so the principal is the red one on my graph there. The green one there is the reference. So the principal plus the reference equals 360 degrees. So the reference is 360 minus the principal. Or if we're in radians, the reference is 2 pi minus the principal. Right? So there I show you all the rules, all summed up. So you already are 0 to 90 and 0 to pi, or 0 to pi halves. So there's nothing to do. In the second quadrant, we're from 90 to 180, or pi halves to pi. In the third quadrant, we're at 180 to 270, or pi to 3 pi halves. And in the fourth quadrant, we're 270 to 360, or 3 pi halves to 2 pi. All right, so what we do depends on what quadrant we're in. Either we're good the way we are, we subtract from 180, we subtract 180, or we subtract from 360. Those are your 4 choices. That's not so hard, is it? And it's easy to figure out because it just depends what quadrant you're in. And you'll know what quadrant you're in because you graphed the angle. So I think it's either the top or the bottom I have in your notes, right? And some examples. I think it's the top, maybe the bottom too. All right, so in quadrant 1, number, we're not worried about it. It just is what it is. In quadrant 2, our reference angle, that's what that's showing in degrees. Our reference angle is 180 minus the principal. So the theta with the little prime symbol is saying reference. So you notice in the graph there that theta with the prime symbol is being referred to as the reference. And just plain old theta is the principal. So if we add those together, we get 180. Therefore, if I subtract the principal from 180, what's left is that reference angle. And as an example, so we have the quadrant 1 example. It's a 60-degree angle who is proudly stating, I am my own reference angle. In the second quadrant, we have a 120-degree angle graphed. So if we subtract 120 from 180, our reference angle is 60 degrees. Right? So now in quadrant 3, right, our reference angle plus our principal adds to, our principal angle plus try it again. Our reference angle plus 180 adds to our principal angle because we've gone more than 180 degrees. So if we subtract 180 or pi from our principal angle, we'll have our reference angle. So now I have an example over here. It's the 240-degree angle. So 240 is more than 180. And if I subtract 180, I'll have my reference angle. So my reference angle in the third quadrant is 60 degrees. And then last, to find the reference angle in the fourth quadrant, we just subtract the principal from 360. Or 2 pi if we're in radians. So the last example is over there. 315 degrees is the principal. If I subtract that from 360, 45 degrees is the reference angle. So there are 4 examples. They're just that simple. Now these were all in degrees, but it's the same working in radians. It's just a little bit different number. Boy, I am glad I did this as 2 podcasts because I'm at 15 minutes, which would have been a 35-minute podcast, and I'm not anywhere near done. But maybe I'm close to done. All right, so we want to determine the reference angle for the 240-degree angle. All right, so I'm in the third quadrant. All right, so I graph my angle, and this lopsided looking thing is my angle. I need to get my reference angle heads from the x back to the x-axis, but I'm not going to go counterclockwise, so I don't want you to think it's going negative. But it's it's the positive difference between the the negative side of the x-axis and that principal angle. So if we're in the third quadrant, all we have to do, and this is 240 degrees right here. So I'll write in black, 240 degrees. Oh, actually, it's up there. That's good enough. It's close enough to where it needs to be. So we're in the third quadrant. We're going to take 240 degrees and subtract 180. So that's going to give us 60 degrees. So equals our reference angle. So 60 degrees is our reference angle. That's simple. Here in the next example, oh, and this, by the way, some of these are in your notes. I do not have a copy of the notes, so I don't know which ones. But you follow along and you fill in your notes, whichever ones it are. So here, this is our principal angle goes to 323. We'll just figure out how many degrees it is to get here, right? And it's going to be we're thinking positive distance. So no matter which way we go, you're thinking positive. So all we have to do, we're in the fourth quadrant here. We're going to take 360 and subtract 323, and that's going to give us our reference angle. And so that would be 37 degrees is our reference angle. Okay, and that's all we have to do. So I hope you're finding this easy. If not, ask me questions in class. Let's do another one. I think we might have some in radian measured coming up. Not yet, 2 more in degrees. It's okay. So here is one we have to find the principal angle, and then we have a negative, so it's good we have these. All right, so here we went, so we have to find a coterminal angle, in other words. Here we went 470 degrees. Well, that's too many degrees in terms of finding a reference angle. I'm going to find a coterminal angle first. So the coterminal angle, right, all I have to do is, I want this to be smaller, right? I've gone around the circle more than once. I'm going to subtract 360. So if I take 470 degrees and subtract 360 degrees, I'm going to get 110 degrees. That's my coterminal angle. And this angle, looking for a color to draw in, this angle here would be my coterminal angle. So that's the coterminal one. And it's only 110 degrees. All right, so now we're in the second quadrant. And we know from this, for the second quadrant, we're going to take 180 degrees. So this is our reference angle equals 180 degrees minus our principal angle. So we want the coterminal principal angle as our principal angle because it's between 0 and 360. 470 is too big. So 180 minus 110 means that our reference angle, and I should have degree symbols on it, our reference angle is 70 degrees. Same thing over here. We want the positive angle. So this is the negative angle. Let's find a coterminal angle. So to find our coterminal angle, we're going to add 360 this time because we're negative. So our coterminal angle is going to be negative 125 plus 360. So that's going to give us 235 degrees, right? Okay, so the negative way is negative 125. The positive way is 235 degrees. We're in the third quadrant. So we're going to take our principal angle and subtract 180 from it. So our reference angle equals 235 degrees minus 180 degrees. So that's going to give us 55 degrees. Right? And that would be the distance here. Right? And actually, I probably should draw it in the positive direction because it's a positive angle we're looking at. So that's that direction here. I didn't draw this one in either. So there's our reference angle. So this is the 55 degree angle, and this one over here is the 70 degree angle. I don't know if I drew them in on the other pages. And the answer is no. So here, this one was 60 degrees, and this one was 37 degrees. So it's that angle that takes us back to the axis, and all you have to do is either subtract 180 degrees, subtract from 180 degrees, subtract 180 degrees, or subtract from 360 degrees, depending on whether you are in the second, third, or fourth quadrants. Wow, I wonder if I'm going to have to do 3 podcasts. Eek. We're at 20 minutes. All right, so here we have some reference angles. We're going to do these ones for radian measure. All right, so 3 pi fourths. I'm going to graph that. 3 pi fourths, actually it's already graphed. I don't know if you can, I hope you can see it. It's the green line there. I can go over it. So this is, right here, is 3 pi fourths. We are in the second quadrant. So to find our reference angle, we're going to take 3 pi fourths. And we're going to subtract pi from it, right? Because 180 degrees is pi. So we're going to subtract, we're going to subtract 3 pi fourths from pi. So, pi minus 3 pi fourths. Decided to write it backwards. So pi is the same as 4 pi fourths. So our reference angle is pi fourths. There it is. So it's this angle right here. And that is our reference angle, pi fourths, which is easy to work with. All right, we have 11 pi 6. I'm going to just kind of outline it. So this is 11 pi 6 right there. All right, so it goes all the way around like this. We're in the fourth quadrant. All right, so that means we're going to subtract from 360. And 360 is the same as 2 pi. So we've got 2 pi minus 11 pi 6. 2 pi is the same as 12 pi 6 minus 11 pi 6 gives us pi 6. So that means our reference angle here is pi 6. So that's this little angle right there is pi 6. Another friendly angle to work with. And then last but not least, we have this one here, 4 pi thirds. So this right here is 4 pi thirds. It goes like that. All right, we are in the third quadrant. 1, 2, 3. All right, so to find our reference angle, we're going to subtract pi from 100 and from our principal angle. So our principal angle is 4 pi thirds. So we've got 4 pi thirds minus pi, and pi is the same as 3 pi thirds. So we have 4 pi thirds minus 3 pi thirds, which is going to give us pi thirds. So our reference angle is pi thirds. So there we go. There we go. All right, so we're done with these 3. All right, so note that x and y have different signs in the various quadrants. Thus, the trig functions will have different signs for the quadrants. All right? So you notice that already when we graph points, sometimes we had positive values and sometimes we had negative values. So here where the trig functions are positive and negative. So everybody, all 6, I think this is in your notes, all 6 are positive when we are in the first quadrant. R is always positive, X is positive, Y is positive, everybody's positive. If we go to the second quadrant, notice that the sine and cosecant are the only positive ones, right? Because that uses R, which is positive, and Y, which is positive. Anybody that's got an X in it is negative, right? So notice those are our 2 positive ones. And notice that sine, the principal one, starts with S. So we have all students. So in the third quadrant, the only two positive ones are the ones that use both negatives, so the two negatives cancel out, and that is tangent and cotangent. Tangent is the principal one, the principal trig function there. So notice it starts with T, all students take. And then in the fourth quadrant, the y is negative, so anybody that uses y is going to be negative. The only two that don't use y is cosine and secant, so they're positive, and cosine, the principal trig function, starts with C. So calculus starts with C as well. So that's how you can remember it. All students take calculus. So all are positive in the first quadrant. Sine and its inverse and its reciprocal, cosecant, are positive in the second quadrant. Tangent and its reciprocal, cotangent, are positive in the third quadrant. And cosine and its reciprocal, secant, are positive in the fourth quadrant. Little mnemonic device there for you. All right, so one last thing. I don't know. Let's see how much I can get done. Although you won't be given x, y, or r, you'll still be able to evaluate the trig functions because these angles are very special. They're special because they are the angles from special right triangles. The angles are multiples of 30, 60, or 45. The reference triangles allow us to determine the trig ratios for these. So this lesson brings everything we've done so far together and connects to things to come. And I'm wondering, maybe I've given you a lot of information, so maybe we will finish this up on Monday. I'm going to do a new closing for you. And I'm just going to put it here because I happen to be here. And so I'm going to do everything but evaluating reference angles. So I'll just put it right here. And this is your closing for your Friday closing. So I've already done almost 40 minutes of podcast, no more than that, 45 minutes or so. So I'm just going to close it. If you've got questions on the first parts I've gone over, evaluating will be tricky. If you're fine with it, evaluating is a piece of cake. It's just putting together what you learned about finding the trig ratios and graphing a reference angle. That's all. So this is going to be your closing. This is for Friday. So what I want you to do is graph. Let's do it in radians, so we're a little bit more familiar with radians. I got to figure out which one I haven't done. I don't even remember anymore. I don't think I've done on the 6th. Let's see. I think 5. Wow, have I done them all? Pi thirds. Let's just do. No, I don't want to do pi thirds because that's already in the first quadrant. Oh, let's graph an angle. Let's do 2 of them. Let's do 2. So let's do 1 in degrees and 1 in radians. So graph a angle measuring 140 degrees. Now find the coterminal angle. Excuse me, the reference angle. And wish I had gotta make sure I don't choose anything. That one's fine. Done that one. There's only so many of them that you can do. So graph, there's only the fourths, the thirds, and the, oh, you know what, I'll just find one that's not a special one because we're just finding reference angles. So the special ones end in 3, 4, and 6. I'm gonna do one that doesn't. Graph an angle measuring, but I don't want to make it too tough for you. How? I'll do it in 12ths. I'll say 11 pi 12ths. Well, 12 is Got a lot of things that divide evenly into it. I guess that's okay. So 11 pi twelfths. Now find the reference angle. Sometimes it's hard to write these off the top of your head. I guess that will be fine. All right, so a little closing there. It's not too difficult. And then tomorrow, on Monday, we're going to pick up with how to graph and evaluate reference angles. It's just so important. I didn't want to, I want to make sure that you understood this stuff first before I go through that. So I'll see you on Monday, and that's where we're going to start with. All right, bye.